Well, we're back to our study of trigonometry, and we're going to introduce two new concepts today. The first one has to do with coterminal angles, and just before we get to that, just a reminder that a standard position angle is an angle in which the initial arm is on the positive x-axis, like that, and the terminal arm is usually somewhere else. Let's just put it there. And if I measure the angle in standard position in a counterclockwise direction, we call that a positively measured angle. So that would be 120 degrees, let's say. If I measure the angle clockwise from standard position, that's a negatively measured angle. So this, let's say, is beta, and that would therefore have to be negative 240 degrees. Now, both of these angles are what we call coterminal because they have the same terminal arm. And that's what a coterminal angle is. Angles in standard position with the same terminal arms. Now, there are actually an infinite number of coterminal angles because, for example, with the 120, it terminates there. But if I add another revolution, if I add another 360, then I come around to another angle that terminates in the same spot. So 120 plus 360, which is 480 degrees, is coterminal to the original two. If I add another 360, (840) is coterminal. Let's go back to my 120. If I go in the other direction from 120, so if I subtract, going clockwise, 360, I get to the negative 240 that I talked about earlier. And again, if I go around clockwise again from negative 240, or subtract 360 twice from 120, however you want to look at that, negative 600. So all of these angles have the same terminal arm as my original 120. They're coterminal. So in general, what we can say is that any standard position angle has coterminal angles given by the original angle in standard position plus or minus 360 times the number of revolutions. So one revolution, n is 1, two revolutions, n is 2. Okay, as many as you want. So there's an infinite number. And of course, this statement here, where n's a natural number, is equivalent to this statement here, where n's an integer. So now I want to talk about measuring angles in radians. And measuring angles in radians is dependent upon us referring to a circle. And so we may have an angle. And the way we measure radians is we take the arc length between the initial and the terminal arm, and we divide by the radius. So the number of radians is equal to the arc length of the circle between the initial and terminal arms divided by the radius of the circle. Okay, and some people like to simplify this just to say the angle in radians is equal to the arc length divided by the radius. Okay. Now what I've tried to draw up above is a situation in which the arc length and the radius are the same. So I've tried to draw this. Imagine if you could measure this arc with a piece of string so that this length here is equal to the radius. Okay? Because if that's true, if this and this are the same, then what I've drawn here is an angle of 1 radian. Okay, just to give you a feeling for what that's about. Okay, and if you want to sort of convert that over to, how much is that in degrees? That's approximately 1 radian is approximately 57.3 degrees. But we need a measure that's a little bit more accurate than that. We can't just say that 1 degree is about 57.3. We want to be more precise about that. So let's work on that idea. What I'm going to do to make this more precise is I'm going to take an angle that I know well in degrees, and specifically I'm going to take a circle of radius r, and I'm going to talk about an angle of 360 degrees. So that would mean that the terminal and initial arms would both be here, and my arc length would be the entire circumference of the circle. So I'm trying to figure out how many radians is 360 degrees using my definition of radians up above. So 360 degrees would be equivalent to, in radians, the length of the arc on this circle. Now the arc on this circle, you say, what's the length of that? Well, that would be the circumference of the circle. So that would be 2 pi r, since that's the circumference formula for a circle, divided by the radius r, which leaves us with 2 pi radians is 360 degrees. If I divide by 2, I could say that pi radians is 180 degrees. Okay. Actually, when I'm dealing with radians, I don't need to use the little r up above. This is optional, so I can take it out. If I'm talking about an angle and I don't put a symbol up above, that's assumed to be radians. Okay. However, with degrees, you have to put the degree symbol. Okay, so we have two important conversions here, and if you want to take this one step further, if you wanted to know how much 1 degree is, you could divide both sides of this equation here by 180, so pi over 180 radians is 1 degree. Or if you wanted to divide this by pi, you would get 180 degrees over pi is 1 radian. And this final statement, if you were to type in to your calculator 180 divided by pi, you would find that that's about 57.3 degrees. Okay, so these formulas here, any of these four versions, are what you're going to use in order to convert between radians and degrees. Alright, I'm asked here to convert 5 pi over 7 radians into degrees. Now, just to talk a little bit about what this all means along the way, other than just doing the question. If I type in 5 pi over 7, as a decimal, that's 2.24 radians. And just as a reminder, a radian is the arc length divided by the radius of the circle. So if I had a circle, and you know what? I'm going to pretend for a moment that my radius of my circle is 1. If the radius is 1, then the number of radians I have is the length of the arc. So basically my arc length is going to be 2.24 times the size of my radius. So, where is this angle approximately? Well, if this is the radius of 1, that's about a unit 1, unit 2, and a little bit. The angle I'm talking about is over here. Okay? So 5 pi over 7 radians means that the length of the arc, assuming the radius is 1, is 2.24. Alright, so how many degrees is that? Now, there are lots of ways to convert between degrees and radians. The way I like to use is unit analysis, in which we want the radians to cancel out, so we're going to put that on the bottom, and the equivalent number of degrees on the top, because that's what we want to convert into. And we know that 180 degrees is pi radians. Okay, so I can multiply these two, simplify the expression. Okay, let's type that in to see what we get. 5 times 180 divided by 7. So this angle is about 128.57 degrees. Now, just as with angles in degrees, we can talk about coterminal angles with radians. So if I have my 5 pi over 7 and I want to get coterminal angles, all I need to do is add or subtract 1 revolution. But keep in mind now that 1 revolution isn't adding or subtracting 360. It would be adding or subtracting 2 pi. 2 pi once, 2 pi twice, etc., etc., where n is a natural number. Or equivalently, where n is an integer.